How can a comet leave a long-lasting tail? Could we see if the Voyagers were destroyed? And could you drive into a lava tube on the moon or Mars? All this and more in today's question show. Hey everyone, it's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I'll answer them here. This is the second question show of the week, and that's because we have made them twice as often, but half the length. And that is like the perfect amount, the perfect snack. Not a space bite, but a questions snack. Anyway, let's get into the questions. Scott Cassidy, how can comets leave trails for tens of thousands of years without withering to nothing? So one of the things that blows people's minds when they learn about this is that meteor showers are caused by the trails left behind from comets, that every time a comet goes around the sun, it's leaving this material behind and then comes back around. It follows roughly the same orbit, but not the exact same orbit. It's sort of following this, spirograph orbit around the sun. It's leaving a trail, a slime trail, like a slug. And so when the Earth passes through these cometary tails, we get meteor showers. And they have very famous names, it's the Perseids and the Leonids. And these happen because the part of the sky that is visible when the Earth is plunging into this trail left behind the comet is where the meteors appear to be coming from. And we know that these trails can last for hundreds of years. So there are various names for various comets, Swift-Tuttle, there's different named comets for each one of the different meteor showers. And one is even an asteroid, Phaethon, but they don't last tens of thousands of years. They last hundreds of years. And we know that the solar wind is always pushing and shoving these tails farther and farther out into space, and they do spread out and become more diffuse over time. And so when a comet has fairly recently gone by and replenished the trail, then we can sometimes get these meteor storms because we're going through this comet tail in a very focused time. But then later on, the material is a lot more diffuse and we pass through it very slowly and sort of but it's interesting, like astronomers have these maps where they can actually have the trails, the different trails that the comets have left behind, and they can chart when the Earth is going to pass through these trails to be able to cause the meteor showers. But they're getting eroded by the radiation and the solar wind, and they're being they are also like evaporating from the radiation from the sun. So they only last for so long. Kyle Miller, if one of the Voyager spacecraft gets destroyed by hitting an asteroid, could we differentiate between that happening and a complete system shutdown? So, in both cases, a complete system shutdown or a meteor strike, Voyager would go offline, that it would not respond to signals. But we wouldn't know what had caused it, only that it is no longer answering our call because Voyager is really far away. And so even if there was a very powerful telescope that was always watching Voyager, just trying to check and make sure there's nothing wrong with that spacecraft, if it did get hit by an asteroid and was obliterated, we wouldn't see it. It's too faint. And so, you can imagine situations where you might be able to tell, like maybe it gets hit by a cosmic ray and it causes some kind of defect in its computer and it starts to spit out gibberish and then it goes offline, then you would know that, okay, it's something computer related. But if it's just the engineers send a bunch of signals to Voyager and they wait for a response and there's no response and they will never know what went wrong with it. And this happens. There have been many spacecraft where they have sent their final command expecting the spacecraft to be in good health and it never returns the call. It just ghosts us. Leon, how possible would it be to drive into a lava tube on the moon? Kind of possible. So when we think about the lava tubes on the moon, our observations of them are from overhead, right? You've got images of lava tubes taken by the Lunar Reconnaissance Orbiter, and we see these skylights on the surface of the moon. But the reality is that, when these things formed, you had lava flows that were coming off of a volcano, that they were moving downhill. They got covered in a crust of lava on the top. And in many cases, the reason you have the tube is because at the end of the journey, the lava was able to come out the end and empty out the tube again. And in many cases, just went out onto the landscape. And so it's believed that you're going to have these exit points, these giant caves that you could just find and walk into. And I don't know of any specifically that have been identified, but I know that they're there. It's very assumed that they're going to be there. And so, you know, the traditional thought is, oh, it's going to be so much work. You're going to have to land near one of these skylights. You're going to have to rappel down potentially hundreds of meters down to the bottom of the tube. It sounds very dangerous. Well, maybe we can find a place where there's an exit and you just drive right in. So could very well be that we can drive into lava tubes on the moon. Some rye. Fraser, I saw on Astronomy Cast that you mentioned your writers are looking for more work. Any chance you can get them to narrate some space bites for us? That we can have more bites and more interviews. I would love to get the writers involved more on the video side and the audio side of what we do. That, you know, one of the concerns that I have with Universe Today is it's very much about me. And that is not what I want. Like, I want it to be that it is this collaboration with all of these writers. But the reality is that I'm the boss and I'm the one who pays the bills. And so I wouldn't feel good about asking them to participate, you know, in interviews and so on, unless I had a structure that I was going to be paying them. Like, if I'm going to have them spend a half an hour doing space bites, then I should be paying them. And so, like, the problem is that there's less and less work to go around for writers. I've had, like, it's kind of amazing. A bunch of our existing team of writers have come to me and they said they need more work, that the other gigs that they have that they were doing freelance writing for, those are all drying up, either like professional things in institutions, whether it's other websites. And then at the same time, people who working in other fields are coming to me and going, hey, have you got any freelance writing work? And I have an infinite amount of ideas for stories and I have lots of projects that I'd love to work on, but I have to pay the bills and I can't afford to. So that really kind of sucks. And, you know, we're seeing declining revenue on Universe Today purely through the advertising. Like, we're down 75 to 90% of the ad revenue that we would make 5 years ago from ad revenue. A big part of that is just that there's a lot of less advertising revenue. There's a lot of AI slop out there that's diluting the amount of ad revenue that's getting paid for everybody. The search engines are now just providing you answers as opposed to sending traffic to the websites. It's getting really hard to be a publisher. And, you know, it feels like we're kind of in the end game now of journalism, of reporting stuff online about people being able to make a living being a freelance writer. And I want, you know, we're so lucky with Universe Today that I identified this trend many years ago and tried to make this big shift over to Patreon. And we're now funded 75% of the organization is with Patreon. We make a little bit of money from the advertising on the website, but very little now. And we make some revenue through the advertising on YouTube. And of course, we try to make the YouTube advertising the absolute bare minimum. But I'm starting to have to figure out how I make cuts because it's not enough. And I would love to do that. Like, yeah, hire the various writers on the team to put in a shift, narrating space bites or getting involved in other parts of what we do. But, you know, I need to figure out how to find money for that. So anyway, join our Patreon, patreon.com/universe today, and then help me hire more writers so we can have this completely independent, ad-free, ideally, organization that is unkillable. And we'll just keep going on forever. But we're not quite there yet. So I have anxiety. If you want to support the work we do at Universe Today, consider joining our Patreon club. Your support lets us have a minimum of ads and no sponsorship messages. Patrons get no ads on universetoday.com for life. Want the extra parts of the live stream that aren't in this edited version? You can sign up for a special patron-only podcast feed and get the overtime segments, as well as other special behind-the-scenes episodes, including our monthly patron-only question show. Thanks to everyone who has already subscribed, and welcome to our recent newcomers: Caradwin, Rob Hawk, John Davis, Marissa's Universe, Andrew Marles, and Michelle Disraeli, and to all our Patreon supporters. Thank you. Josh Tawney, does the fact that the moon is receding from the Earth impact our tides and weather systems in any meaningful way over time? No, not in any meaningful way that we can detect, but it's significant when you think about the fact that early on, when the moon formed out of the rubble of whatever it was that hit the Earth and the Earth turned every few hours. And then as this object, the moon, started to drift away from the Earth's rotation started to slow down, and now we have our 24-hour day length. But this process is ongoing, and so every year that goes by, the moon shifts away about another 1.5 centimeters, I think, and the Earth's rotation speed slows down a little bit. And what they're moving towards is this far, far future day when the Earth and the moon will be tidally locked to each other. Right now, the moon always shows the same face to the Earth, but the Earth is still turning. But eventually, the Earth and the moon will share the same face at each other, staring forever. But of course, that won't happen until long after the sun dies. I think it's 50 billion years from now, when the Earth will finally tidally lock to the moon. Back to your question, no, the change is very small, but it was a lot more significant early on in the history when the moon was a lot closer, and it was making the shift fairly quickly. And it's believed that, in fact, the most of the movement of the moon's moving away from the Earth happened early on, that it's not like this smooth distancing away from the Earth, that in fact it happened very quickly and then has slowed down over time. Space or bust? Any thoughts on whether space relays will overtake more traditional ground stations as the primary means of communication with commercial satellites, whether in LEO or beyond? I'm a huge fan of this idea of space-based infrastructure. So right now, when you think about the way we communicate with spacecraft, it's very much that there are a bunch of giant radio dishes around the Earth. They're clustered in 3 different regions. So there's some in Europe, some in Australia and Asia, and some in the United States. And that allows continuous communication with spacecraft depending on sort of how the Earth is rotating. And yet those giant radio dishes are completely oversubscribed. You can actually go to NASA's Deep Space Network and you can see which dish is communicating with which spacecraft. This is communicating with Curiosity. That one's communicating with Perseverance. This is communicating with the Voyagers. That is communicating with James Webb, downloading data, and so on. And they're all busy. And that's just because, I guess it's a good problem to have. We have a lot of spacecraft and they have a lot of data to send home. But part of the problem as well is that the amount of bandwidth that a spacecraft can send home goes down the farther away the spacecraft is. And so when you had spacecraft all the way out to Pluto, right, with New Horizons, it took it 18 months to send data home at just a couple of bits per second, which is very different from something that's in low Earth orbit. The International Space Station can transmit at megabit speeds. And I'll explain, that's not exactly accurate because space station is using a relay. But anyway, the point is the farther away you are, the less bandwidth that you're able to send home. And so you have to target one of these giant radio dishes at New Horizons and just listen and listen and listen for what could have just been transmitted in a short burst. So there's a couple of really exciting developments that have been made. The first one is the addition of a infrared laser communication system. And this was put onto NASA's Psyche mission. This is, of course, the spacecraft Psyche that's going to be visiting the metal asteroid Psyche. But as part of this mission, the spacecraft is carrying a transmitter that allows it to communicate back and forth with Earth using an infrared laser. And the amount of bandwidth that they're getting, the throughput, is enormous, orders of magnitude better than trying to communicate with a radio system. They send home cat videos and things like that. And that's great. And so you can imagine, with these successful tests, every single future spacecraft is going to be equipped with some version of this laser transmission system. It's just so much faster. But then you have this idea of relays. And so, the International Space Station has recently been tested. There's a satellite where it was able to send its communications to the satellite, and then they are transmitted back to Earth at very high speed. And they've been able to dramatically increase the bandwidth available to the International Space Station and give them sort of better coverage, at different times of the day and not just when the ground station is directly below the space station. And I love this idea of infrastructure that will have this future where there will be communication satellites with really good high power lasers situated in various places around the solar system. And so then instead of a spacecraft having to carry this giant transmitter on board just so it can send home a couple of bits per second, that all it has to do is be able to reach the relay station, send its data there. The relay station sends home giant packages of data back home to Earth. It's picked up by the appropriate equipment that's maybe always staring at the system. And then over time, as we get more spacecraft, more relays out there, we get this better and better transmission. And I think, we talk about these ideas of us sending humans to Mars and maybe one day we'll live on Mars and so on. It's the infrastructure that will tell us that things are going on that path, that you want to see the infrastructure knowing that, okay, once I start to see the communications infrastructure, once I start to see the power infrastructure, the logistics, the cargo, then the likelihood of humans being able to live on Mars, live out in space, is going to become a lot more likely. Marco Locatelli. Fraser, would it be possible to create localized magnetic fields to protect a crew temporarily on the surface of a moon or planet without one? So this is a question that people always have, which is that we know that here on Earth, the magnetosphere protects us from the vast majority of the radiation coming from the sun, as well as the more damaging cosmic rays that once they hit the Earth's magnetosphere, they're rerouted around and we are kept a lot safer. Like, I think if you were on the surface of the moon, you would experience about 200 times more radiation than you do here on the surface of the Earth, protected by the magnetosphere. And in fact, the astronauts on board the International Space Station are protected by the magnetosphere. So when astronauts actually go to the moon or Mars, they're going to be taking that radiation right on the chin. And so the question is, well, if Earth has a magnetosphere, couldn't we build a magnetosphere on another world? And, in theory, sure. But the problem is that the amount of electricity that's required to generate a magnetic field that is equivalent to the magnetic field that you experience here on Earth is pretty big. And on a place like Mars or a place like the moon, I always like this, like, what are the three most important things when you're out in space? They are power, power, and power, right? So there's going to be a lot of need for power on the moon or Mars, and to go and spend some of that really valuable power trying to run electricity in a giant wire coil and try to mount that wire coil around your station. Why not just dirt? Just pile up some dirt, you get a meter of regolith, and that will give you the same level of protection as some kind of artificial magnetosphere. It will block it. And so I think piling dirt on top of your station is the low-tech solution that will be as effective as trying to come up with some kind of magnetosphere. And, for spacecraft, you don't have dirt. And so, maybe we could use that same technique for spacecraft. And the reality is that so far, and there's been a ton, like, people have been thinking about this idea for probably 50 years. And, I've reported on this many times. You can go back through the NASA archives and look at each paper that says, we're going to attempt to create an artificial magnetosphere to protect astronauts in spaceflight. And the conclusion that they always come to is it takes too much power, that it's better to just bring dirt, be willing to pay the cost to take your dirt to space, take water, surround your spacecraft in a layer of water, and that will protect you from the radiation. That the simple ideas are still cheaper, more effective than trying to come up with some high-tech solution to be able to do it. And if there is some, if we have superconducting, then maybe someone will get to this point where we can incorporate a superconductor into the spacecraft, cool it down to the right temperature, and maybe that's going to work. But right now, I could point you at dozens of papers where people have attempted to do this, and they all come to the same conclusion: too expensive, too hard, not ready. All right, those are all the questions that we had this week. Thank you everyone who asked their questions in the YouTube comments. Thanks to everyone who showed up for the live stream, which we record on Mondays. There'll be a link to the next upcoming live stream here on the channel. Now, I'm going to talk about a sort of surprising benefit that I give to the people who join my Patreon. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Andrew M. Gross, Barry Lake Roofing, David Gilton, and David Matz, Dennis Alberti, Justin Cable, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Paul Rohrbach, Spiderswap.io, Stephen Fowler Munley, and Vlad Shiplin, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So I just crossed an interesting milestone, which is that I just completed my 800th personal interview with a patron. And that is something that I don't tell you that I do, which is that when you sign up to become a patron of Universe Today, I reach out and ask if you want to do an interview with me. And now many of the people who are watching this, you know, you've experienced this interview. And yes, it's actually me. Yes, we will actually talk. I have questions for you that I want to understand, how you see our content, what kinds of stuff we do really well, how you think we can improve, who else does great content that maybe I can get inspired by. And so when you become a patron, this is one of the things that you get. And so normally I don't tell anybody, but I figured, you know, because I'm trying to demonstrate how much value I'm trying to bring with Patreon, that I wanted to let you know this is a thing that we do. And maybe I'll never talk about it again. But so yeah, go to patreon.com/universe today. Sign up. You'll get access to the patron-only podcast feed. You'll get all the ads removed from Universe Today. You'll get all of the behind-the-scenes content, all that additional stuff, and chat with me. All right, we'll see you next time.